Welcome, everybody. I would like to talk about the patient behavior-guided nursing in neonatal intensive care. I am Judit Varga and work in the Department of Obstetrics and Gynecology. We have the vision that sleep-protective nursing of neonates leads a better neurodevelopment outcome later in life and a better quality of life. And our mission is to seek techniques to make it come true. We investigate an already existing one, which is called Ectography. It measures sleep in children as well. And we would like to develop another brand new equipment, which is a camera-based equipment and would make observation of behavior of infants possible. Let's see our first project, diagnostic accuracy of ectography compared to polysomnography in children. The prevalence of sleep disorder in childhood is very high, and there are several methods for evaluating this sleep complaint. The gold standard is polysomnography, which is, however, a very complicated procedure and requires huge hospital resources. There exists another equipment called Ectography, which also measures sleep, but it is cheap and easy to use and makes long-term measurements possible. And our aim is to evaluate this easy-to-use tool reference to polysomnography. Ectography works with an accelerometer, which converts motion into electric sign, and the data will be downloaded to the computer. And two consecutive algorithms decides about sleep and wake for each epoch of time, for example, 30-second epochs. One gives an activity count and another decides whether it is asleep or wake. You can see here the data from an actigraph where there is no motion. In the blue area, it is sleep. And polysomnography, of course, operates more precisely with EEG, ECG, and electromyography also. They do not coincidence always. Sleep medicine is quite complicated. It contains heterogeneous group of sleep disorders. There are several diagnostic tools, and Ectography is just one of them. In childhood, the American Academy of Sleep Medicine suggests in special cases the use of Ectography. In insomnia disorder, circadian rhythm sleep-wake disorder, central disorders are hypersomnolence, but it is not useful in periodically movement disorder. Let's see our outcomes. So we would like to measure the sleep parameters with Ectography and polysomnography. There are several sleep parameters. Let's concentrate on total sleep time. It is quite easy. All the time called as sleep in the green area from the total measurement. And wake after sleep onset is all the time scored as wake after the sleep onset, so after sleep begins until the sleep ends. And how can we compare the two methods? The first method is an easy one, but seems to be the best one. When we compare the measurements of the two methods and take the difference of the measurements. And from many measurements, we will have a mean difference, and this represents the bias between the measurements of the polysomnography and ectography. The other method is to compare each epoch of the measurements, whether it is sleep by ectography and also by polysomnography. And when polysomnography measures sleep and ectography measures sleep, it will be a true sleep. And it gives us the sensitivity and specificity and accuracy. And an additional analysis when we take correlation into consideration. We included studies where we had data from children from one overnight measurement with ectography and concurrently with polysomnography, and we found 27 articles. So if this is my first plot, if we plot the mean differences of the measurement of total sleep time from ectography and polysomnography, we get this forest plot. When ectography underestimates, so it gives lower values, then we have positive bias. When it's overestimate, we get negative bias. For example, in the first article, ectography overestimated sleep by 76 minutes during one night period. And we see that the heterogeneity is very high, so we shouldn't concentrate really on the pooled effect. But we should concentrate that what this high heterogeneity causes. It is because of the work of ectography. It sometimes incorrectly classifies a period as wake when there is a high activity during sleep, and vice versa. When there is a low activity during wake, then it incorrectly classifies as sleep. And there exist systematic discrepancies, but we cannot tell this is systematic, while sometimes it overestimates, sometimes it underestimates. So and these systematic discrepancies can differ in different populations and different ectograph models, algorithms used, threshold settings, and so on. So we try to make subgroup analysis according to age, but we get the same results. Under 6 years of age, it rather tends to underestimate sleep measurements. It can be because under 6 age children moves a lot in sleep phases. And we also check the in sleep disorders, and so the first group are the data from a patient without sleep disorders, and the second is from patient who tends to have sleep disorders. It is interesting that it shows that it's the agreement is more in patients with sleep disorders. So if we see the sensitivity and specificity plots, we have an overall sensitivity of 90%. Sensitivity is the proportion of minutes that ectography accurately identifies as sleep. So 1 out of 10 is incorrect from the identification. And in case of specificity, wake identification is even worse. And correlation is also not very high, considering that it measures the same parameter on the same population. 0.75 is not enough. And we plan further analysis according to different ectography devices and variety of algorithms. Maybe this high heterogeneity can be considered a bit more. We selected the most uniform data that were available, and non-uniform data reporting hinders data pooling really much. It is a very easy to use tool, so we would like to find algorithms that are usable in childhood. Our other project is a camera-based observation of behavior in infants in neonatal intensive care. We have a camera-based system with an attached computer system with machine, which...
Excuse me, Judit, time is up.
Okay. Thank you very much. And thank you for your attention. Everything is theoretically impossible until it is done.
My first question is that we are supposing that polysomnography is the gold standard and Ectography is compared with it. And you told us you have different algorithms, different devices. Are there devices which are performing better or which are seem to be equivalent or more equivalent as the others, or is it a project to analyze it in the future?
Yes, we are searching for, there are several algorithms and threshold settings in case of ectography, and we would like to search for appropriate one, for example, in infants or appropriate one in adolescent, because they can be different, which is more usable. It can be different in different age groups and different populations.
Because maybe there are already validation studies at the market or somewhere, and you could then search which were validated and which had the best results.
So the problem is that there is no validated sleep times with an ectograph, so there is no really validated studies.